So what do we do first?
We need ClO3 minus goes to the Cl minus.
And the other one?
Iodine minus 2, iodine 2.
Okay, then what?
Balance everything but oxygen.
So chlorine stays the same, so then we add water to no, we did, what did we do?
How many waters?
3.
That gives us 3 oxygens on the right and 3 oxygens on the left.
Yeah.
So yeah, first we balance the oxygens
Then we
using
have
water.
6 protons on this side.
Now we balance the protons. Actually, we missed something.
What do you mean?
First, you balance the non-hydrogens and non-oxygens.
What did we do?
First, you balance the non-oxygens and non-hydrogens. Now, so let's back up for a second. I'll let that mess us up here. So the chlorines here are already balanced. But what do we have to do here?
Oh, you mean
That's easy to forget because some problems you don't need to do that. But I think we talked about, in your notes, I think we put that in the method. So first you balance the non-oxygens and non-hydrogens using stoichiometric coefficients. So here we have to put in this 2. The chlorines here are balanced. Now we balance the oxygens using water. So 3 waters. Now we balance the hydrogens using protons. So that would give us 6 protons. That doesn't seem to apply down here. Am I getting this right so far?
Yeah.
Okay. Now what?
the same as second? No, what's, do we need to go? Ah, no.
Go to the second one.
There's no oxygens here to balance, and there's no protons here to balance. All right, so let's start with this one. How would we balance the charge here?
Put
2 electrons on that side.
Right. Notice that if you hadn't put this 2 here, you wouldn't know how many electrons you need over here. So it's very important that we did this first. And this is the tricky one. Let's do this one on paper. What do we get there?
plus 6.
4, so
6
it's
minus
minus 1.
1
It's
plus
5.
4 plus 4
So it's just plus
electrons.
6.
No,
Minus
plus 4
4
electrons.
electrons on
Because
this.
that one side is minus 1 and we need to minus 1.
Minus 4
Plus 1
electrons.
here.
So it's U plus 6 electrons.
Good. All right, I think that's right. Although I would have a criticism, which is I think that you guys were all doing that in words rather than on paper. How would you do that on paper? Well, what is the net charge on the left right now?
Plus 5.
6 minus 1 is 5. And what's the net charge on the right?
Minus 1.
All right, so I need to add a bunch of electrons here, 6 electrons. For me, it's much easier if you write down the initial net charges. But I think what you guys said was right. We need 6 electrons. 5 minus 6 is 1. All right, and now we do have electrons on opposite sides. You should always get the electrons on opposite sides. If the electrons don't come out on opposite sides, we must have made a mistake in the earlier steps, because otherwise the reaction wouldn't make sense. You can't have everybody being reduced or everybody being oxidized. They shouldn't set up a problem like that. All right, I guess we might as well finish this off. So what do we do now?
You add multiply the bottom by 3.
Can't add them until we multiply this by 3. Now we balance electrons. Now we balance electrons by multiplying. So I multiply this by 3, which gives me 6 iodides, 3 iodines plus 6 electrons. Now we can add these together. That gives us ClO3 minus plus 6 H plus. Oh. Now we should be putting in the phases, so this would be aqueous plus 6 H plus, aqueous plus 6 I minus, aqueous forms Cl minus, aqueous plus 3H2O plus. If you look at the original, this problem I didn't give it, but I think iodine is a solid. So I wrote that as iodine solid. Did I get this right?
Yeah.
And the electrons cancel.
I know where I made a mistake.
Yeah?
Yeah, I put the electrons not
On the
on
wrong
this
side,
side,
right?
on the wrong side where it's iodine minus.
All right.
Okay, so when
Yeah.
iodine minus and 2 electrons would give you the.
Okay. Maybe you just didn't balance the charge right then using the electrons.
Yeah, so we always wanted, so this one is reduced. No, this one is oxidizing.
Is this an oxidation or a reduction?
Oxidize.
It's gaining electrons.
It's gaining
so
electrons.
It's
It's a
reduction.
Yeah.
reduction.
this is gaining these electrons. That looks like one, that's the thing that messes students up a lot, so that's still a good thing to review before the test. These are gaining these electrons. So GR, gain of electrons, is reduction, and this is losing the electrons into space. So that was loss of electrons, which was an oxidation. Always, one of the half reactions will be an oxidation and one will be a reduction. And if they don't come out that way, you just have to go back and check your work. You must have made a mistake somewhere along the way.
So whenever we have like in first half like plus 6 electrons, for example, it means that it's gaining, yeah, plus.
Yes.
And if it's on the other side, then it's going to be as a lost electron.
That's right. Yeah.
Oh.
You can memorize that. It should also make sense if you think about it, but you can also just memorize this. We are adding 6 electrons to here. So this is gaining those 6 electrons. And here, this went through a reaction, and at the end, it didn't have these electrons anymore. So it lost those electrons. That's right.
ClO3 minus is the oxidizing agent.
This is getting reduced, so yes, it must be the oxidizing agent. That's right. I always find it easier first to say who's oxidized and who's reduced, and then the agents are the opposites of that. That's right. This is being reduced. So this is the oxidizing agent, and this is being oxidized, so it's the reducing agent. That's right.
So how comes that sometimes they put like, for example, if it's metal compounds, they put only like metal, like instead of like putting the whole compound. Like for example, here will be reducing agent ClO3 minus, but in some parts where you do like, do you remember like with metal compound, you put just metal.
Right. I don't know. That can happen with either a metal or a non-metal. You're right. People are a little ambiguous when they say the oxidizing agent. When they ask you for the oxidizing or the reducing agent, they could mean what's the molecule that's the oxidizing or the reducing agent, or what's the ion, or they could mean what's the atom that's the oxidizing or the reducing agent.
Sometimes it has like chromium O3, and when I put like chromium O3, it says right, but then if like it's, I think with silver something was, and I put silver as a whole compound, it said like, no,
it asks
it's
for
a,
element, that's
yeah,
why.
oh, it says
asks
like,
for element.
oh, okay.
Right.
That's again,
And
that's
if
right.
you even put the state, if you put like state after it, then it's gonna be wrong. They just want like if it's sulfur, just put an S.
Okay, so they put like compound and an element, or.
Yeah, read
They
what
say-
they ask for.
No, they say like
Because
reducing agent or oxidizing agent. So
Which-
they don't really say like if it's a complex or if it's, I mean, or if it's.
You'll have to learn what the conventions are. So yeah, unfortunately, the computerized homework systems can be very picky. So when they ask you for the oxidizing agent, you could say 2 things here. You could say that the compound, which is the oxidizing agent, is the ClO3 minus. Or you could say that the atom or element that's the oxidizing agent is the chlorine, because that's the element whose oxidation number is actually changing. The oxygen, if you worked it out, would have an oxidation number of -2 on both sides. It's the chlorine whose oxidation number is actually changing. We've seen that you don't actually have to figure out the oxidation numbers to balance redox reactions, but if you want to know exactly which element is being oxidized or reduced, you would see it's the chlorine over here. After all, this chlorine has a +5 oxidation number, and here it has a -1 oxidation number. So it's gaining lots of electrons, not the oxygen, which has a -2 oxidation number here and -2 oxidation number over here as well. So yeah, if they ask you for an oxidizing or reducing agent, they could be asking for either the compound or the element. If the homework software is well written, they should specify which one it is. If it's not so well written, they might have a convention that you're expected to know, and I guess you have to do trial and error to figure out which one it is. It kind of sounds to me like when they want the element, they say element. And if they just say oxidizing agent or reducing agent, they mean the compound, just from hearing and listening to you guys talk. I don't know if they're even consistent about that, but you'll have to work that out on your own. Okay.
Yeah.
Okay, well, we did a bunch of examples of these together, so it's good to do another example to make sure you're going to get the points if you see these on the test. It's easy to make careless mistakes on these problems, so that's where the practice comes in.